Okay, week 6 we are looking at sampling, and this video is just going to be a short video looking at the key messages from week 6. Okay, so the idea around sampling is that if we select some things from the population, that group of things will hopefully be able to tell us some information about the whole population. Now, the word population in statistics does not necessarily mean people, although it could be people. So for example, let's say we're interested in potential product defects for the previous model Toyota Corolla in Australia. The Toyota Corolla has had some airbag problems in the previous model. So we may define our population of interest to be all Corollas that are still in working order. Now, it'd be impractical to check every single Corolla in Australia to find out the proportion that have a defective airbag. So we may take a sample, let's say 100 Corollas, and from those selected, hopefully we'll be able to learn something about the population of all Corollas in Australia. So in this example, a population element is an individual Toyota Corolla, and the sampling frame or the sample frame is the listing of all Corollas that we are going to draw our sample from. Okay, so why should we sample? So the alternative to sampling is to take a census. A census is where every single element in the population is measured or examined. So in the previous example regarding Toyota Corollas, that showed that it would just be impractical to take a census due to the costs and the time involved in having a look at every single Toyota Corolla in Australia. So another reason why we might sample, if testing of a population element requires breaking the item or testing it until it fails, this can be thought of as a type of destructive testing. So after testing the population elements, the item is effectively useless. So in situations like this, we'd be forced to take a sample, because if we didn't, in doing the testing, we would end up destroying every element in the population. So when we take a sample, we're able to determine a sample statistic. This sample statistic can be used to estimate the population parameter. Okay, so back to the Corolla example, we may be interested in the proportion of Corollas that have the airbag defect. So if we sample 100 cars and 12 of them have problems with the airbag, then we have a sample statistic of 6% of cars with defects. So we can use that sample statistic to make a guess at what the population proportion of Corollas is with defects. So a good guess would be, well, 6%. But in addition to this, based on the sample, we can also come up with a range of values with which we think that population parameter sits between. So for example, we might say we're pretty confident that the population proportion, or the proportion of corollas in Australia with airbag defects, lies between 4% and 8%. And that's an example of a confidence interval, and that's something that we deal with later on in the course. Okay, so the steps in sampling. So back to the corolla example. If the population of interest is all usable corollas in Australia, then this is our target population. Our parameter of interest could be the proportion that have airbag defects. Now, looking at the sampling frame, how do we go about getting a list of all corollas that we can choose our sample from? So this is often a problem when coming up with a sampling strategy, is how to get a good sampling frame or sample frame. So we could go to the motor registry for each state and get a list of all the owners with Toyota Corollas. But what about the people that bought the cars unregistered, or that own them unregistered and they're still in working order? The registry won't have records of those, so they will not be in our sampling frame, and they basically won't be able to be included in a sample that we take. So we need to choose what sample method is appropriate, and we need to work out what sample size is required. So the sample size is based on how good we require our estimate to be. So the better we want our estimate to be, the more data that we need to collect. Okay, so for simple random sampling, this is where each population element has an equal chance of being selected as a sample element. So if we look at this grid of values, or this grid of colours here, if we think of the whole grey area, or every single box as the population, the yellow items are the items that we are going to add to our sample. And if they're just chosen purely at random, then that would be an example of a simple random sample. And this is usually done by looking at the sampling frame and using some sort of random number generator. Okay, so another sampling method is systematic. So for systematic sampling, we simply choose a random starting point and choose every kth element in the list after that. So the interval between each sample element can be worked out by looking at what the sample size is required to be, and the size of the whole sampling frame. So with systematic sampling, let's say you decide to select every 7th element, for example, and then let's also assume you're dealing with daily data. You may end up selecting data points that are on the same day each time. Okay, so this is an opportunity, or it's there's a possibility here that you may have some bias in your sample due to that. So one way around that would be to randomize the order of the sample frame. Okay, so for stratified sampling, the population is divided into subpopulations or strata, and then simple random sampling is used on each strata. So again, using the corolla example, we may choose to stratify by state and then randomly select elements from each state. And the number of corollas that we choose in each state might be proportional to the number of corollas that were sold in that particular state. Alright, so another sampling method is cluster sampling. So for cluster sampling, we select groups or clusters and we add them all to our sample. So back to the corolla example, we might allocate cars sold in cities to clusters, and then we may create our sample by randomly selecting, say, 2 cities, and let's say those 2 cities are Newcastle and Wollongong. Then our sample will be made up of all the corollas sold in Wollongong and Newcastle. Okay, so non-probability sampling is where the probability of selecting elements is unknown. So these sampling methods tend to increase the chances of our sample being biased. So convenience sampling or convenience samples are non-probability samples where the element selection is based on ease of accessibility. So for example, if a particular burger shop was interested in what people's favourite burger shop was in Newcastle, and they asked their own customers while they were in the shop, this would be an example of convenience sampling. And here there is clearly a risk of bias being introduced in the results, because if the customers are in that particular burger shop, then chances are they already like that shop. So that the results of that testing are likely to be skewed in favour of that particular burger shop. Okay, so the key information from this week, I guess, is why do we sample? What is the need for us to sample? And then the different types of sampling methods that we have available. All right, that's it for the week. Thank you.